Good morning, everybody. We're just going to give a minute or two for people to join, and then we will get started. All right, appears that the attendees are leveling off nicely. Good morning, everybody. I'm Willem Klumpenhouwer. I'll probably end up introducing myself a couple times through the course of this, but I'm your moderator for this session. Thanks for joining us. We're going to be talking about policy applications using automated data. So we've got 5 really interesting presentations, policy applications with data-driven policy and advocacy is very near and dear to my heart. So I'm really excited to hear what people have to say. Just a reminder, you heard Brendan mention that presentations are lightning presentations, which means that presenters will have 6 minutes, and I'm going to be pretty strict about the timing. We've already chatted about that. But if during the presentation you hear me say or sing the word ding, it means that we're approaching the end, about 30 seconds left. So just so you know, in case I interrupt people, that's what's happening. I'll remind you, there's no live Q&A during the presentations, lightning presentations, because of time. If you're interested in something somebody said or you have some follow-up questions, there is a document linked in the Union Station page next to this session link. So there, you'll see a Q&A link. That's a Google document. Then you can put your question in there, and I encourage the presenters. The presenters will go and check it out. And maybe bookmark a link to it so they can check up later and follow up on those questions if needed. The session is being recorded, just as an FYI, so we will be providing that kind of thing later. If you have any technical questions, you can use the chat box if there's some technical issues to send me and the panelists a message. I will keep an eye on that as best I can. As well as the Q&A. If we do have some time at the end, we might be able to get to some Q&A. We only have 5 presenters for this session, but not generally going to happen. So without further ado, I think we might as well get started with the presentation. So first, our first presenter is going to be Kiarash. He's going to talk about a new paradigm of equity in transportation modeling. And Kiarash, if you'd like to unmute and start your video and share your screen, you can take over. I will get myself a timer ready. And I will,
Let me.
Yep, that's all right. I'm not going to start it till you're until you're ready to go.
Okay, sorry. Okay. I'm Kiarash. I'm a PhD candidate in Istanbul Technical University. And in this presentation, I'm going to talk about a new paradigm of the equity in transportation modeling. And equity is could be defined as a fairness in access to the transport choices, and understanding the equity implication of transport policy and investments are the important factor for a policymaker. We think that I couldn't change my. Excuse me. We think that and hypothesize that the regular user, because of the high possibility of occurrence, according to their high frequency and trip rate, are overrepresented and weighted in modeling and analyzing procedure. And for this aim, we focus on impact of frequency of traveler in a long period, and also their transaction rate or trip rate in this during an impact on a public transport modeling. And also I have a small talk about the frequency dimension of equity. In this context, we work with the Kocaeli municipality data related to the whole area of their providence. In this term, we use the Python for tracking the household ID, unique ID in data, and categorize according to the number of their frequency in whole period. The data is a big and approximately more than 12 million boarding and transaction. In the right side, there's a two table that on top is related to the number of the distribution according to the category of the users. According number of day the user card holder is used their card in public transport. The black line is in a whole data distribution of the card holder, and the blue one is the number of the user or card holder in average one day, and the orange one is the orange one is the card holder, and the other one, blue one, is transaction or number of the boarding in average one day. As you see, if you look the one day, there's a huge impact in a regular user which are using more and frequently, and the number of the non-regular user is low. And if we categorize the users, the user between the 1 and 2 day and 1 and 6 days boarding are presenting 66% of whole data. However, they presented 22% in one data. And inversely, the number of the ratio of the regular users in whole data is 16. However, in the one day is 39%. Also, in the bottom graphic, if you see the trip rate or transaction rate of each category is increased, and therefore the regular user has a higher transaction rate than the non-regular user. For compare more based on the routes, we compare two different routes. One is a 118 and the other one is 23 bus line. If you look, the number of the users in the daily users in the 118 is higher than the 23. However, when you look at the whole data period, it's clearly that the number of the 23 is more than the 118. It's a reason of the frequency of users, and it shows that if you look at the one day, the result is different and the number of the exact user is different. In this study, we understand that in evaluation and planning the transport, we are generally look at the trip and the daily user and boarding. However, we should look at the user base in long periods. And also, some routes are used by more people. Even the number of the boarding is rare on one day, such as the medical needs or route is currently for this aim. For this study, we understand that frequency could also for considered an evaluation of inequity or equity in the transportation. And beside this, it's possible to evaluate the impact of the intervention of new investments in transportation. Thank you for listening. I'm ready to any question related to my presentation.
Great, thanks a lot, Kiarash. And yeah, once again, if you have any questions, follow that Google Drive link to ask your questions later on. Rick, if you want to share your screen, thank you. Give me a second here to reset my timer, and feel free to start whenever you're ready.
So good morning, everybody. My name's Rick, and I'm a master's candidate at University of Toronto, Department of Civil and Mineral Engineering. And today I'll be presenting on a social equity lens on bus bridging and ride-hailing responses to unplanned subway disruptions. So starting with our literature review, we noticed around 3 main topics. So first, we note that for transit equity, there's still significant populations in Canada that experience transit poverty. And while it may be horizontally equitable, for vertical equity, it's not completely the case. The TTC in Toronto, they use a system called bus bridging for unexpected subway delays or major subway shutdowns. So this means that buses are being pulled from across the routes across the city to be used as subway replacement shuttles, but there's no dedicated pool of drivers or vehicles. And in terms of ride sharing, such as Uber and Lyft, or what the city of Toronto likes to classify as private transportation companies, PTCs, they generally have an affluent user base and are increasingly relied upon as a method of commuting and mitigating subway delays or shutdowns. So this leads us to our 2 main equity questions. Are marginalized communities penalized by bus bridging? And do Uber and Lyft respond to every subway disruption equally? So to start off, we categorize each bus route in the TTC system, if they're equity route or non-equity route shown in red. And these routes are routes that mainly serve visible minority communities who tend to have a lower household income than non-visible minorities. Also, we use neighborhood improvement areas, which are defined by the City of Toronto as neighborhoods that are at risk and need increased investment and services. These neighborhoods are shown in blue on the map. And generally, equity routes are concentrated in the outlying suburbs of Toronto and are also generally further away from the subway network. For our workflow, we use data from a number of different sources. So from the city itself, we have origin, destination, Uber and Lyft data, as well as data for neighborhoods and a database of subway delays or shutdowns. From the TDC, we got a data of for each shuttle that's used for bus bridging, which route it came from and when it was diverted. And we use the census to define equity routes. As an initial exercise, we mapped out for all subway delays where the buses are coming from the routes to be used for bus bridging, and also to what degree the Uber and Lyft pickups change whenever there's a subway delay. And we noticed a couple of trends common to all sections of the subway network that we analyzed. So generally, there's an increase in Uber and Lyft pickups near the subway delay whenever there's major subway disruption. And also routes are coming from across the city and they're not just being pulled from nearby routes. This isn't quite true for all sections of the subway. For Line 3 in Scarborough, which is a region with high visible minorities, there isn't the same degree of increase in Uber and Lyft pickups whenever there's a subway shutdown. When we looked at Uber and Lyft specifically, we used the measure called the Geddes-Ord measure, which the p-value measures statistically significant hotspots. In this case, the hotspots of Uber and Lyft pickups. We expect that for neighborhoods close to a subway delay, there will be a smaller p-value or significant increase in Uber and Lyft pickups, which is true for all neighborhoods as shown in the chart on the left. But for neighborhood improvement areas, we didn't see the same level of significant increase in Uber and Lyft pickups as we do in other neighborhoods, even if the neighborhood was almost adjacent to the subway delay. We also accounted for the false discovery rate and looked at it in different lens. So for whenever a subway delay or shutdown at the station is located over 6 kilometers to the nearest neighborhood improvement area, we found that 14 neighborhoods on average experience a significant increase in Uber and Lyft pickups. But that goes down to 7 neighborhoods when it's close to neighborhood improvement areas or under 2 kilometers. For transit, we looked at where the shuttles are coming from and how much and to what degree the capacity loss for each route is. We saw that up to 70% to 80% of shuttles for bus bridging are coming from what we defined as equity routes. But this is a lot higher than what we expected, since 57% of the TDC's capacity is devoted to equity routes in normal operations. And one possible explanation is that equity routes are generally the highest frequency routes in Toronto's transportation system. So we came up with 3 main equity conclusions. So irrespective of vehicle allocation for bus bridging, the long deadheading times for many of these routes that are farther away from the subway network means that residents in these marginalized communities that are high and visible minorities are being affected by bus bridging for longer periods of time and experience capacity loss also for longer periods of time. But even when we count for vehicle allocation, they're also suffering greater capacity loss in terms of more buses are being pulled for bus bridging. And Uber and Lyft activity during subway delays is not equal across the entire city. So some neighborhoods will have higher increase in Uber and Lyft pickups compared to others during subway delays. So thanks for listening, and I'll be sure to answer any questions in the Google Doc later.
Thank you very much, Rick. Alfred, if you can unmute, share your screen. Good, we can see your screen. Feel free to put it in presentation mode and start whenever you're ready. Oh, you're currently still muted.
Yes.
There we go. Go for it.
Yeah, data-driven analysis in support of a fair reform is presented by my colleague, André, and myself from the Transit Authority of Montreal. So one of the mandates of the Transit Authority is to completely revise the fare structure. We want to go from a multiple operator-based fare structure to a single integrated fare structure. We are not done yet. We are about halfway there. We will begin public consultation very soon. The objective for us technical advisors is to evaluate the quantitative impact of different fare scenario, but the limit is it is impractical to exhaustively analyze all the impacts of all proposed scenario at the most detailed level. So we chose a funnel approach and data-driven analysis instead of using a complex data calibrated model. So in the beginning, we test multiple scenarios in order to narrow them down to a few ones based on 2 major performance indicators, the overall revenue and the overall ridership. We try to eliminate as many as possible by demonstrating some doesn't even work at the highest level. So we don't want to lose time and effort to go into further details. At this level, we use traditional household travel survey data, not automated data. And all the trips are grouped into all these segment, mode, and user categories. We try to derive the current fare and the new fare of the scenario. We simplify it to the monthly pass fare, which is about 70% of our ridership use a monthly pass. So the performance measures are then calculated. Going further forward, with the number of scenarios narrowed down, we try to do more, analyze the impact in more details, such as change in revenue and ridership by segment and by individual. In the bottom here, we have We can generate analysis and figure for different scenario for comparison. Major region in the territory by mode, and how many people are going to have a higher fare, neutral fare, or lower fare, by percentage of how much higher and how much lower. We can generate this kind of analysis. And as we push even forward with remaining 1 or 2 scenario, we try to integrate more operational data, such as a smart card automated fare collection system. We integrate fare information, sales volume, exact fare, and seasonality in our analysis, so that we can be more precise about what would really happen in a detailed level. So based on the OD path, each fare segment will be matched with the new fare. So it is essential to prepare implementation schedule and to make sure prepare for the change management. And with this kind of data, we can reduce dependence on many hypotheses, such as expansion factor from traditional OD survey. We can use exact fare instead of monthly fare. We can know exactly what rebate are those people benefiting. This we can, it's just a graphical display of different segments within the region. So in this sector, we have like 6 different segments using like 20 or 30 different fare products. I have hidden the volume and the new fare, but it is used to determine the exact impact for each subcategory of users. So what we have learned from this, the data-driven analysis is excellent in describing the present. We cannot go too wrong for the near future, because it's almost, we start with almost the reality. The data are explicit and therefore more transparent, and the complex model have a lot of simplification on fare choices. It is easier to explain, understand, and identify mistakes. And it is more scalable, and we can do more sensitivity analysis and adjustment on parameters. We mix and match traditional and automated data, and some qualitative aspect of the fare reform cannot be considered in quantitative analysis. So that's all. Thank you very much.
Great. Thank you very much, Alfred. Yuval, you're up next. Before we get started, I'll make a call right now that we're going to have a little bit of time at the end. So if anybody has any curiosities or questions that you think the panelists can answer pretty quickly, feel free to pop them in the Zoom Q&A. So if you use the Q&A button at the bottom of the Zoom screen, you're welcome to put a few questions there, and we'll see if we can get to them. And as always, if there are any further questions, there's a Google Doc link on the Union page. So Yuval, you're up.
Yes. So, hello everybody. I'm Yuval from Bar-Ilan University in Israel, and this is a joint work with one of my postdocs, Genadi, Birfir. And the motivation, I think, is quite clear. We all know that using smart card has numerous advantages over cash payment. I think obviously it's faster and less variable boarding time, which contribute to a better service. And for us, researchers and practitioners, we have a better, richer data to use for analysis. So in that line, the Israeli Ministry of Transport decided to move on to a mandatory smart card only scheme. And as you can see, in 2 largest cities in Israel, it was implemented 2 years ago and a year ago. Obviously, this year it was supposed to be a nationwide, but you know the situation, so it was a bit of postponed. Anyway, there was numerous complaints related to the preparation, specifically from vulnerable groups like senior citizens, low income, about charging, acquiring the card, and so on. So the objective is quite clear. How can we identify areas, bus stops clusters, that there is a high usage of cash, or a relatively high cash payment ratio? So the methodology is, once again, not so complex. We are using local statistics, specifically the get is odd, a G-local statistic, which in a way calculate for each location. You can see that in the map, a weighted average of the attribute we are analyzing. And the weight is a function of the distance, with usually a certain of a cutoff distance from which we are not considering other locations. So we are calculating the weighted average, and based on that value, it's not so difficult to calculate the z-score, p-values, and identify the cold spots and hot spots. We use for the analysis QGIS for the hotspot analysis and Geoda for the spatial regression. It's based on the Israeli Ministry of Transport nationwide PD data, GTFS and AFC. You can see on the right on the map the location of all the stops in the country. And of course, the color represent the number of transactions per day. In this case, it's for representative regular midday weekday. Obviously, in Israel, we use a lot of smart card. And you can see in the pie chart that, for instance, 36% of bus stops use only smart cards, but there are certain areas that still people use cash, and we like to identify these areas. So if you look at the results, on the nationwide outlook, we set up the cutoff distance for 1 kilometer, and the function was the inverse of the distance. And of course, the attribute was the ratio between the cash transactions and the total transaction per bus stop. And on the left map, we can see the actual attribute, the X, and the darker, the more smart card transactions are being used. However, if you're looking at the hotspots and cold spots, you see that the picture is much more clearer, and you can identify areas in which we need to focus our attention and find ways to increase the use of smart cards. And the cold spots are the 3 major metropolitan areas. That's quite obvious. Now, we need to pay close attention when we'd like to look on the localized or regional analysis, because if we are considering the nationwide data on the left map, then of course, this specific city of Haifa, all the bus stops are cold spots, which are perfect. But if you look at the local mean and variance, then of course we can quite nicely identify areas in which there is a concentration of high level of cash usage, which means that in that area we can find ways to improve and find ways to leverage and increase the usage of smart cards. The last example of the results is the comparison with the spatial regression, another city. We used for that city some socio-demographic parameters, but the results weren't very good. You can see that the R-squared, which is very, very low. However, once again, the local statistics provide us quite nice results, identification of the areas where we need to pay attention and find how to increase the smart cards usage. So, to conclude, we use spatial statistics to identify bus stop clusters which have relatively high cash payment transaction ratios. Once we identify these clusters, it's much more easier to focus the analysis on the local passenger profiles, the socio-demographic characteristics, and other related parameters in order to find ways to increase the level of smart card usage. Thank you very much. And of course, question later.
Great. Thank you, Yuval, very much. Yeah, once again, looks like we're going to have a little bit of time at the end. So if you have any questions that you'd like to put into the Q&A on the Zoom chat, we may be able to get to them. So feel free to ask some questions. Now, I suppose it's my turn to share. I'll set myself a timer here. I'm going to, there we go. All right, great. Hi, everyone. My name is Willem. I've introduced myself. I'm a postdoctoral fellow at the University of Toronto's Transit Analytics Lab. As you can see from the fact that I'm acting kind of as a moderator, a presenter, and a Zoom host at the same time right now, I'm someone who likes to wear a lot of different hats. And when it comes to transit, I've worn the hat both, of course, of a user, a student, a researcher, a consultant, a government employee, and an advocate. But for the next 5.5 minutes, I'm going to do something a little bit different. I'm going to put on my advocacy hat, and I'm going to take you on a tour of what I think are some great data-driven transit advocacy projects. And I also want to raise a sort of call to action for governments and agencies and researchers and consultants, maybe echoing a little bit of what we heard from Brendan and Nigel this morning. So I feel our public discourse today is filled with a lot of sort of polarizing politics and opinion and misinformation and fear. And transit isn't really immune to that. There's misinformation campaigns like the one here in Arizona and featured on Patriot Act with Hassan Minhaj. They're more common than you think with transit projects, and often they obfuscate the benefits of these systems with doubts about costs or more ridiculously in this picture, crime. And combating this misinformation requires really raising the conversation with good data analysis and visualization. And agencies do a really good job to try to espouse the benefits of projects, but reaching a diverse group of people requires communities and local advocacy organizations to be sort of armed with sound evidence. And that's where advocates and advocacy comes in. To me, data-driven transit advocacy is fairly simple. It's about making a meaningful and quantitative connection between transit project and a particular community issue or value. So let's have a little bit of a look here. The advocacy and the analysis can get quite sophisticated if the resources are there. So Transit Alliance in Miami has run a number of really highly successful and ingenious data-driven transit campaigns. On the top of this slide, you can see Transit Time Index map, which explains the differences between transit travel times and auto travel times from a given origin. And on the bottom is their Metro audit, which shows on-time performance, both real-time and historical, which really lends data to people's lived experience and validates, the struggles that they might be having with their transit planning. Transit Center tracks national transit ridership at a very granular level, and it lets organizations and individuals see the big picture and also look at these little local nuances and issues. So these are two really great examples of sophisticated sort of advocacy-based transit data analysis, but I don't think these should be exceptions. These should be commonplace. They should be kind of standard in every transit agency in every major city all across the world. But they're not, and often the data that is needed for this type of analysis isn't made public either. So, for example, reliability information is extremely hard to find consistently in transit agencies. It's certainly not ubiquitous. Here in Toronto, we have a nice reliability scorecard that was introduced during Andy Byford's time, but it doesn't provide, there's no long-term time series or at least easily accessible time series database of this type of thing. And this even this type of scorecard is rare among transit agencies. But my experience has shown me that in most cases, the data is there. It's being collected, it's being stored and tracked and analyzed. And none of the information I've ever used for any type of advocacy or I've seen used for any type of advocacy required personal or commercially sensitive data. So my question is, why is it not being shared? And I suspect there's sort of two main reasons: risk aversion and lack of technical resources. Maybe it can be misunderstood or misinterpreted or interpreted differently, or perhaps there's just a mistake in the data, which is always a fear. But not releasing it to the public is, to me, a mistake. Showing your data, showing your work, and showing all of it is really important to establish that public trust. So what can we do about it? My call to action here is for both researchers and academics, as well as governments. So researchers and academics, we scrape a lot of data. We go through all sorts of nitty gritty with a lot of this data when we don't get it directly from transit agencies. And we need to make that type of data public and easily accessible. You can work with university librarians. They can help you make this type of data public. There's lots of different ways to share your data. And you also, it's also great to share your research in multiple ways using sort of accessible visualizations and interactive visualizations. So people can sort of see the story that is going on in your research in an accessible way and in a way that isn't too technical, and they can tell their own stories with your data. And my call for governments is that, make every scrap of data that you have that isn't obviously personally or even commercially sensitive available to the public. You'll never know how it might get used ingeniously to advocate for better transit, for a better city. These can include things like inventories of vehicles and maintenance records, and modeling forecasts and outputs that are used to make these billion-dollar transit decisions, and at a granular level. And reliability information, as I mentioned before. These are all great things that should be made public, but typically aren't. There's some great tools out there. For example, there's Open Transit Indicator, which was developed by the World Bank. It lets the user sort of adjust and visualize and plan your transit system, all with a sort of standard set of data inputs that is usually available everywhere. This is something that every transit agency could host, and should be sort of a commonplace thing. It's worth looking at. So we really need to inject evidence and data into our everyday conversation, and we need to have conversations that capture quantitatively the needs and goals of communities, and we need to push for transparency and transit planning and evaluation. So my call to action is it's time to step up our open data game even more. So thank you. And then I will take off my advocacy hat and put on my moderator hat, and stop sharing, and we'll see if we have any questions. We've got a few minutes here. We've got about 10 minutes, it looks like. Oh, 20 minutes even. So if anybody has any questions, feel free to post them in the Q&A document. We'll give it a couple minutes, and otherwise we will take a little bit of an early lunch break. But I'll give it just a minute. Hi, Rick, we've got a question for you. Omar is asking what parameters you use to flag your equity routes. If you're able to answer that, or if you're still around.
Yeah, so we did it strictly off of the visible minority from the census. So we use census 7 nation areas, which is around like 900 to 1,000 population in each zone, and then determined by visible minority proportions, and if it was adequate for that area to be for that route to be determined as an equity route. So right now it's just visible minorities, but I think future work could involve more factors such as recent immigrants or percent of carless households or other factors.
Great. Thanks. Any other questions? All right, if we have no other questions, I'll thank everybody who is participating, who came and watched us. Thanks to all of our panelists, Alfred, Kiarash, Rick, and Yuval, and myself, I suppose, for joining us for this important topic. I'll remind you, if you're a Twitter user, tweet using hashtag transitdata2020. Get it a buzz. Feel free to talk about what we've been discussing today thus far. Once we leave this, oh sure, here we go. Now I'm getting some questions. Perfect. All right, I can describe a little bit the visualization tool from the World Bank in a little more detail. It is accessed. It was developed by a consulting company, I believe. I don't have their exact number, but if you search open transit indicators, you'll see that as a first result on Google. It was developed to allow you to, there's a GitHub. It takes a little bit of setting up and hosting. Once you have it set up, you can insert your GTFS data. If you have any population data, something from your census, it'll allow you to insert that as well. And a lot of it covers sort of visualizing different routes, different types of accessibility, different types of indicators, access to jobs if there's any, if that data is all available. So it's worth going in and playing around, and it's designed in part to be used a little bit as a transit planning tool, but it can also definitely be used as a visualization tool, as you saw the screenshot there. Suppose I won't answer that live. Is there a canonical list for all the data that should be open? My sort of opinion is that if we're making decisions about it using that data, and if it is shareable, and there doesn't need to be not shared for personal reasons, we should share it. I think that there are certain types of data that we wouldn't possibly know how someone might be able to use it, but yet if we share it and people are able to use it in a way that promotes important views and perspectives, I think that that's really important. So in part, it's hard to have a list because you wouldn't want to exclude anything from it, in my opinion. Again, personally sensitive and commercially sensitive data is always a bit of a different question, but a lot of that type of data can be anonymized quite easily. All right, for Alfred. Alfred, did you get any more information from your research on elasticities? It's a question from Brendan. Alfred, are you still there?
Yes, the answer is not really. We still use the fairly generalized assumption from the literature, and well, we haven't got further on this topic.
Okay. You can hear my cat, as always, in the background. Just take a second to read these questions. Go with here in the EU, new directive mandates the publication of transit schedules format. I haven't had any experience with the NetX Siri format, so I'm afraid I can't answer that one. I'm guessing maybe there might be some interesting things to talk about in the transit data quality and governance, I believe it is, session, and perhaps the one thereafter as well. So that might be something to, if there's some time in that panel to ask there. And I'm also unfortunately not familiar. There's a question about the Section 508 compliance with the American for Disabilities Act. There are ways to try and make that compliance. I'm not familiar with the direct Section 508 compliance, and so I don't want to answer that question definitively. But I think it's it's important to have it, and making it accessible is obviously important. But in some cases, it's better to have it a little bit than not at all, I suppose. Alfred, I got a follow-up for you. Do you have any personal thoughts of whether the Opus data could be used in the future to get more insights on elasticities?
Those are really hard questions.
That's good. They're Brendan's questions. That's why.
I don't know. Anybody here has, has some views on that?
Has anybody else used Opus data?
And smart card data in general?
Maybe Brendan's interested in your personal thoughts.
No, I really don't. It's a pity.
Great
we would
research
like
question.
to discuss it further when we have an occasion.
Yeah, absolutely. Absolutely. It seems that one should be able to do it by using before and after analysis of ridership is his follow-up. Sounds like a good research question, Brendan. So we'll leave it to people to dig into. All right, I'll give it one more second for a little bit more questions if they're there. Otherwise, we will wrap up. Last time when I was about to leave, a bunch of people asked questions. So. Give it just a minute. Okay. All right. Thanks again, everybody, for participating. Thanks for the questions. I'm glad we got to have a little bit of interactivity. Again, if you have any follow-up questions or you want to get in touch with somebody, there's the Google Drive link on the Union Station page. Great way to have a bit more of a conversation, perhaps through email or in a Zoom meeting, or maybe sometime in the future over a drink. Oh, good. Good to know. I'm going to, I'll wrap up the session for now and have a good lunch. We will be back with a video presentation at 1 o'clock. So you can follow the link for that presentation. Thank you.
Thank you and bye-bye.